Great. Well, welcome everybody. So happy and pleased that Katie Holbacher from Beyond Efficiency and her colleague Cara Roussel could join us today. They're really going to take us through kind of an overview of their thoughts about addressing ventilation and air quality in our projects and focus on residential, but they'll touch on commercial as well. So with that, take it away, Katie.
Hi, everyone. Thanks for inviting us to present on this. There, obviously, air quality, given wildfire smoke, COVID, and just pollution is high in everyone's mind. So we think it's a great topic. A lot of you, I'm sure, have worked with my colleague, Dan Johnson. He's usually the face you see from Beyond Efficiency. We thought we'd mix it up a little bit today. So again, like Mercedes said, Kara and I are presenting today. I'll do most of it and ask her to kind of ask questions throughout. And in terms of just sort of asking questions, chat, are there any kind of protocols we should talk about, Mercedes or Don? We're open to whatever you guys want to do. Okay. I think there is a lot of stuff we'll go over, and we can either choose to just sort of power through it and then have ample time for Q&A or mix it in. Do you guys have a preference?
Anyone on in the group have a particular preference, or Donald, do you have one way that you see it works better?
It's up to the presenters, I think, but there is a bit of a rambunctious tradition at Small Firm Forum where people get inspired by something they see and they can't wait to ask a question. So there is that.
Well, why don't we plan on this? If there's a question relevant to what we're talking about, Mercedes or Don, you can either choose to invite someone to ask it or just, kind of let us know what comes up in the chat, because I won't be monitoring the chat. No problem. And if there's something really off topic or it seems like we're going down the rabbit hole, someone can police that and not let me go there.
I'll do my best. Yeah.
Okay.
Sounds good.
Okay, great. Well, we'll jump right in. Beyond Efficiency, we're high performance building consultants. We also do mechanical engineering, and we'll leave it at that. You can learn more on our website if you don't already know who we are. So this slide on the front, this is a passive house we had consulted on a number of years ago in Carmel. And different from the kind of iconic ideal of passive house that a lot of people think of, there was a direct range hood over the gas stove that I pretty much insisted on for air quality, and that's one of many things we'll be getting into today. And let's see. Okay, there we go. So Mercedes, did you actually take this picture, or was this from?
No, I screenshotted it from a newspaper.
Okay, got it. I'm like, that's pretty impressive shot.
Isn't it?
So I'm actually not in Berkeley anymore. I'm in Wyoming. But yeah, on this morning, people were slacking pictures to each other about oh, it's like Armageddon in the Bay Area. And I mean, how horrifying to have been there during this. Really, yeah, pretty crazy stuff. And 2 days later actually seems to be when the bad air quality peaked in the Bay Area, even though it looked worse on this day. And as you guys all know who were there, it was unhealthy and very unhealthy throughout the Bay Area and all of Northern California. And in terms of the traditional, the key metric that's usually looked at in terms of poor air quality from smoke, it's parts per million and of particulates. And again, what we're seeing here is between kind of 150 and in the 200s, which is awful. And luckily, used to be a rare thing, definitely happening more often now. I think it's really good, though, to step back and actually get perspective of how the air quality we experience during wildfires, how it compares to what a lot of people worldwide are experiencing often just on a regular day. So this was yesterday. I think it was kind of early morning when I did the screenshot there in that time zone. But we have India here, China here. It's poor air quality in kind of, large swaths of these countries. And, really, really terrible what people have to endure. And this is zooming in a little bit on Northeast China. There are some fires around, but this is pollution. And, again, a lot of coal burning still to heat buildings and homes. But, as bad as it is for us when it's bad, we are fortunate in a lot of ways that it does still tend to be a discrete time period. It might be a few days or a week where it's really bad. Now, of course, we do still need to be very concerned about air quality. I'm not saying like, oh, we have it really, really well and we shouldn't worry about it. But it's good to step back and have some perspective about that we are fortunate in the US compared to a lot of the world. And this just came from this organization, IQ Air. And according to them, don't know, where this information comes from, but they claim air pollution causes 1 in 9 deaths. And that's, pretty horrifying. So we can do better. And then closer to home in California, there have been studies showing, clear connections between proximity to freeways and asthma rates. And unfortunately, that's often where land is cheap and where a lot of affordable housing projects go up. And that's one of our main areas of work at Beyond Efficiency, are these affordable housing projects. And they've found that, asthma rates will about double when someone does live in a unit that is, again, very close to the highway. And this was a pretty fascinating article in the LA Times that was out a few years ago that just showed how, even though they've known this is a jurisdiction and have tried to just in theory want to discourage housing from going up in these places, there are still thousands of units going up on a yearly basis in areas where it makes people really sick to live. So what can we do about it? So it's always helpful, regardless of the issue at hand or the challenge you're trying to deal with, to try to get upstream of the problem. Again, the term in this book, solve problems before they happen, try to eliminate the issue from the outset. So we'll get into just high level best practices on what that means. How do we go about minimizing pollutants really by design? The next step is then to dilute the pollutants that are in a home, a commercial space, a school. And some of those are brought in from outdoors. Some of them, again, are emitted from products and materials. And some of them are just from ourselves, by cooking, by breathing. And then the last thing, and really it should be a last resort in most cases, is to clean the air. So whatever's left in there that you can't get, you couldn't eliminate from the start, or you couldn't dilute, now we just need to try to remove them through air cleaning. And again, please do ask questions, post to the chat if anything comes up. So what does source control mean? These are pictures of, unfortunately not that uncommon, a picture of someone's crawl space. There might have been a plumbing leak up here. This can rot plywood, cause mold, obviously lead to breathing issues, cause people to be sick. So I think of, oops, jumped ahead here. Let's go back. So one thing I think everyone's very aware of is just the importance of thoughtfully specifying materials to reduce emissions. And we're in, California is ahead of the game through a lot of the CARBs, the California Air Resources Board requirements that have come out to reduce emissions from wood, from pressed wood products, reduce fire retardants or eliminate them, and things like children's clothing. Arlene Bloom right there in Berkeley has been amazing in that regard. And we're not going to talk more about it, but that's certainly one place to focus efforts, to just be thoughtful in what you're specifying. Furniture is a big one here too. And mold is a really big one. Proper rainwater management, reviewing piping before everything's closed in, getting on top of leaks immediately when they happen, and just specifying proper building assemblies. If you're doing some sort of new wall approach that's never been done, make sure you aren't trapping moisture in a place where it could cause sheathing to rot and cause mold. So then this is one of the areas we're going to get into a lot more detail on. The focus of today will mainly be on mechanical systems, but for mechanical systems to really work properly and be able to provide the best indoor air quality that they can, it is important to pair that with an airtight enough building envelope. So we will get into this quite a bit in the next couple of slides. And radon, luckily, it's not too much of an issue in the Bay Area, but radon, for those of you who don't know, just naturally occurring radioactive breakdown of underlying rock that is especially prevalent in mountainous areas. And in California, it's the worst in Santa Barbara and also in parts of the Sierra. But radon is a really big deal. It's the second leading cause of lung cancer in the country after smoking. So if you want to learn more about it, this is something, oh, by the way, we'll definitely PDF these slides and send them all. And if there are resources we mention, we'll try to include those as well. But so radon would be another thing. Again, you want to eliminate the issue before it gets into the home, rather than just trying to dilute it once it's there. So then the next step is ventilation. And the purpose of that is, again, to dilute pollutants. There are pollutants that build up. If you have an adequate number of air changes, meaning you're completely turning over a certain volume of a space in an hour, and you have designed that properly based on the space and the occupancy, then you really right there should end up with quite good air quality. There are various ways to go about accomplishing mechanical ventilation, and we're going to get into a number of the options from code minimum, which we at our company really don't believe does much for air quality, to the premium, which would be a balanced system with heat recovery. So what this is showing here, this is a schematic of what a whole house ducted heat recovery ventilation system would look like. A number of you, I'm sure, are very familiar with HRVs or ERVs, and we're not going to talk too much about it, but essentially it is a box like this, and fresh outdoor air flows through it while the stale indoor moist air is flowing out, and they pass over each other through an engineered heat recovery matrix in a way that will, again, exchange a high percentage of the energy, but without actually mixing the air. So, this is definitely our ideal if it can ever work in a project in terms of budget and the constraints of space of running ducts and things. It is by far the best solution for air quality. And again, we'll get into a lot more on that. And the ideal way to do a balanced system like a heat recovery whole house, or again, whole office system, would be that you duct the fresh supply air to living spaces and offices in the case of a commercial building, or bedrooms in the case of a bedroom, and you exhaust from those areas that are releasing pollutants, moist air from bathrooms, the entry area where there's a bunch of muddy, wet stuff, the pantry, and we'll again get more into that. So why do we encourage balance? With more and more projects if you're doing a new project in the Bay Area, gas is, again, you just can't even use gas anymore. Certainly, there are plenty of places in California where people are still doing new gas hookups, but it's still definitely an issue with a lot of renovations. If someone just put in a new gas furnace a couple of years ago and they're doing a remodel, it might be hard for them to justify going to an all-electric system. So the concern you can have with a ventilation system that isn't balanced, and again, this is the typical ventilation system in a home in the Bay Area, is just having an exhaust fan on all the time, or just using it intermittently. So every time that fan is on, it depressurizes the home. You have your clothes dryer running that's vented. You have the range hood over the kitchen. There are all these things we use that will, again, induce depressurization, and that can cause backdrafting of these combustion appliances. So that's really the most important reason to have a balanced system, is to try to, again, prevent backdrafting. But even when that's not an issue, having a balanced system is better. It's best for efficiency and some other reasons that we'll get more into. Again, this isn't a requirement, but definitely something we really like to see and encourage. So then you've tried to eliminate pollutants at the source. You've now diluted them, but gosh, we're still left with pollutants. So what do we do? And this is where, again, just a plug-in air filtration device can be very effective. This is just an example of many products out. The market's been flooded with a lot of these products. And I'm not putting this out here as something that works or we recommend. I haven't used it, but it's just an example of kind of the scale of these. This is one that's about 2 feet tall, and it has a high level of HEPA filtration, meaning just a very small particulate size this can filter. And I do say here, ideally, this is a last resort, because again, this is just a Band-Aid. It's not getting to the root of the problem. But if someone's a renter in an apartment, or suddenly there's all this wildfire smoke and someone can't just turn around and air seal their home and put in a properly designed ventilation system, this can be a really good thing to do for those, kind of acute periods of time. So I do want to spend a bit talking about the importance of enclosure airtightness. You think of air quality and you're like, oh, we need ventilation. But again, good air quality in a building, you really do need to look at it from the standpoint of whole systems and how all these different aspects of a building interact. So, why do we care about air tightness? Some of the obvious reasons, if you have less air exfiltration or cold air infiltrating, you're going to save energy, reduce heating and cooling bills. Has benefits of just reducing sound transmission, can make a building safer in case there is a fire. It helps minimize mold. But from the standpoint of indoor air quality, there's probably a number of you on the call, and don't worry, we won't do a poll or anything, but this idea that but if we make it too airtight, now we suffocate in the space and it's unhealthy. But the best approach really is this notion of build tight, ventilate right. The tighter you have a building envelope, the more control you then have over what the appropriate amount of air exchange is under certain conditions. Or you are able to potentially, turn that mechanical system totally off or turn it to very low levels when you do have, a purple day on the air quality map. So this is, again, a really important aspect of source control of what you're bringing in. And to do a properly air sealed building, and again, in a remodel, adequate air sealing can be challenging, but I think the real idea is, well, what's possible? Given the scope of a project, what are the opportunities, and how can we do a good job? So a good process we encourage is just take all of your key sections through a building that are that comprise your various conditions. You have a sloped roof, you have a flat roof, you have various intersections, you have a slab on grade, you have a buried wall, and really go around item by item and think about how are you accomplishing air tightness here, or how are you transitioning from air tightness at this flat roof over to this wall. And when you really add them all up, there can be a lot of conditions. So that's it's an important step. It's not that hard to do, but when you do go through that thoughtful process, you'll often find oh yeah, I didn't think about this particular detail, or how we're going to make sure that we accomplish air tightness. So in terms of our one of our best practices that we try to incorporate in our projects is to designate the structural sheathing as the primary airtight layer. You can read up about how you do airtightness in a building and find lots of different strategies and solutions. There's definitely not always an obvious best choice, but why we really do prefer, in terms of the walls, focusing on the structural sheathing, is that it's it has good integrity, right? It's stiff. You're not trying to air seal something soft. And typical construction on the projects we're all working on always have structural sheathing, not necessarily in a remodel, that's a different situation. And since you need a drainage plane, you can use these materials that are excellent drainage planes to handle rainwater and can also double as airtight barriers. And these are just, and then basically your options there are a zip system. This is OSB with a pre-applied drainage plane. You then only have to deal with the seams. A self-adhered membrane. This is an example of that by Vapor Shield. Oops. And then you have some kind of spray on or roll-on products. You can definitely accomplish airtightness in an easier way. You can just have regular plywood or OSB, tape the seams, and then do a regular kind of less expensive membrane. And that's a good, kind of first step if any of these other solutions seem to, are out of budget or otherwise too challenging. Another really important thing I don't have noted on here, but that the sill plate to concrete wall connection is always a major weak point. It's really easy to put a gasket under here, or one of our clients actually has gotten creative with the use of pond liner because it's cheap. You can cut it to whatever thick width you need, and it's nice and thick and will compress. So again, they actually use pond liner to manage air tightness again at this really critical interface. And some often projects, if you're looking at a new project, it's pretty clear that you need to do a crawl space or you need to do slab on grade. If there is a choice, we ourselves recommend and prefer crawl spaces because then there's space to run equipment. And as mechanical designers, it's often a challenge of ours of finding trying to find adequate space to run ducts and everything. The ducts are then warm if you condition this and insulate the walls, makes future-proofing easier. And again, actually, it doesn't actually facilitate radon mitigation. You can do definitely perfectly adequate radon mitigation with a slab on grade. I probably should take that off. And then it's great to have, certainly you want to think about integrating air tightness details into every detail and think and make sure you're capturing everything, but there are always issues or penetrations on a project where you're just not going to have a detail. So something we really like to do is just think comprehensively, what are all the different conditions? If we're trying to maintain this seamless airtight barrier, where are all the areas that's going to be compromised, or what's our strategy for dealing with it? And so this is a good exercise that can help, again, find things that might otherwise have been weren't on your checklist to look at. And this in parallel with references to a building section and then individual details is just one of, one good strategy to help you get to good air tightness. And then pulling it all together on a dedicated plan sheet. And this is just, again, an excerpt from one of our projects we worked on. So air tightness is one of those things that if you are setting, if you are serious about achieving a level of air tightness that seems appropriate for the project, and we, again, would always say, set something, whether you're going to set it as something pretty aggressive or just something a little better than typical, it's really not that hard to get right. And it's just, doing it, having someone that is responsible on a job site for making sure that new holes that have been made by the electrician when they came out to put in a new circuit or something are dealt with. And you really can't rely on subs to do this. Someone does need to be designated. This is Terry Nordby. I'm sure a number of you know him. He has developed this term called, you need an ass on the job site, the air sealing specialist. And it could be anyone, if it's a homeowner, just kind of tracking work on their project, it could be that person. It could be just a site supervisor. It doesn't really matter who it is. It doesn't matter who it is so much as having someone that does have that responsibility. And blower door testing, we, again, always encourage is a best practice, and we really would love to see it as just a given. And something I would encourage all you to do, if it's not already something you're just weaving into your projects as a given, that you should be integrating blower door testing. And if you need it for Title 24 compliance and it's actually on those Title 24 HERS documents, it needs to be done at the end of the project. At that point, it's really just a rubber stamp. If you don't have the level of airtightness you were targeting at the end of the project, you might be able to make some adjustments at that point, but it's pretty tough. So what you really want to do is have a couple of blower door tests done during construction, so that you can use that to make improvements before you've closed everything up. So these are the key parts of the process we encourage. The first one would be after exterior sheathing in windows, before insulation. Do a test then, and then after all the trades are done in insulation, but pre-drywall, and then finally at the end. So now we get to move on to mechanical. Any questions on that stuff before we dive into the, I think where most of the interest is going to be today?
Yeah, there were some questions. One of them is, Donald asks, are the old-fashioned leaky homes a better quality animal, or we could also say, how do those rate or stand compared to, obviously it's a different thing than what you're recommending, but can you comment on that?
Are old-fashioned leaky homes better than newer homes from the air quality?
I guess maybe the question might be, and Donald, you could jump in, but for example, if there's no ventilation system, no mechanical ventilation system to make up the difference for air, or the client's not going to do a mechanical ventilation system, then does that, Donald, I'm interpreting your question, so feel free to jump in.
I'll just say that that question occurred to me just before Katie talked about leaky homes. So
okay,
I kind of get her position on
Okay.
that. Thank you.
Sure. I had a quick question about during the framing stage with the air sealing, and on an ADU recently working with Dan, we did do the air sealing on the plywood with the kind of tape and some of the other measures. And it didn't seem like it added that much time, but really I didn't get the data on all of that. So I'm just trying to get a kind of sense of, let's say it's a 2-bedroom house that's getting remodeled, or an ADU of some size. You could pick the size. How much time, like in terms of number of hours or days, it might add, just so I have a kind of a sense of what that might be. And is that usually, like in our case on the ADU, it was done by the contractor. Of course, a HERS person, I guess, could do it, but since it's part of the building envelope, we want the contractor to be responsible for all of it. Any comments on any of that?
Yeah, I mean, air sealing would certainly be in the contractor's scope of work. If you have a good HERS rater, or just, an envelope focused quality assurance person, it would be great for them to do that QA kind of in parallel with a blower door test. But otherwise, yeah, you want the contractor to be doing the work. Definitely agree with that. There are, in the cases of remodels, there are some home performance specialist contractors that really are skilled in this work. It can be kind of tricky of how you best deal with air sealing in an attic or a crawl space. So there are a number of home performance contractors around that, might be a specialty contractor you're bringing for some of those things. I think in a new home, a new project, there's adequate, it's usually easy enough to figure it out at the design stage. And then as long as that contractor is supported with like, hey, remember these things are special, so maybe we could mock up a wall before you run full speed ahead. Those would probably be good strategies. But in terms of the time, like everything, what's your baseline? So, we try to establish in our projects that the baseline for walls is a fully adhered weather-resistant barrier. Whether it is zip sheathing, or it's a self-adhered membrane, or it is something rolled or sprayed on, we're trying to look at that as just a baseline now. It is more expensive than just floppy Tyvek, which has will never be an air barrier, no matter how you try to detail it. And the walls are typically, such the weak point in homes, and that if that's already accomplished, there really isn't a whole lot more to do. I mean, again, I talked about that sill plate. There are always tricky things, like if you have rafters, depending on how your attic or roof is detailed, there are often conditions where you want to seal around every piece of blocking in a certain assembly. So that can all take time, but again, as long as it's thought through before and it's clear what you need to do. I mean, I would think one person a full day could often accomplish like the what we really term added work. I don't know if
That
that's
makes
accurate,
sense.
but
Yeah, but get a sense of it, and I can start to talk to the contractors too. Okay, thank you. I don't
Can
have
I
any
have a
other.
quick question?
Oh,
maybe?
sure. Sorry, one quick. You can, yes, and then there's the one after
Yeah.
that too.
Katie, a quick question on the fully adhered, the zip sheathing. I think your annotation said that it's applied to OSB, but in terms of permeability, plywood is better than OSB. Do you have a concern about the permeability of the assembly?
I don't. I agree. So basically what Dietmar is saying is OSB and plywood, like if they're dry, they both have roughly the same permeability or ability to, let water vapor through. But as soon as they get wet, plywood permeability increases, which is good. If it gets wet, you want it to dry out. Whereas OSB, because of all the glues in it, tends to kind of hold that same perm rating. And I would just say this. I mean, something else we always encourage as a best practice, and I don't want to spend too much time on this because I think mechanical is really what we're trying to focus on today. But, this is just thinking about airtightness and the lens I'm trying to talk about it today. But another way to really turn a good wall into a great wall is to always incorporate rain screen detailing. So, so what that would mean, basically, if you have this wall and you want to do, you're going to do hardy siding rather than just installing that directly. I'm just assuming right now we're not doing continuous rigid insulation, but rather than just having the cladding directly against siding, you put in either furring strips or you can put in a kind of a drainage mat. And I can direct you to, we actually have a list of these products on a database we could direct you to. And it's an added step, it is an added cost, but just the ability to make that cladding, what we call back ventilated, it just adds so much resilience to the assembly. So aside from that, would there be a concern with OSB? I haven't seen issues with it. And, and that's even though OSB, when it's trimmed, is supposed to be sealed before it's installed. I've never seen anyone do that on a job site. We haven't seen OSB cause a problem because it's OSB as opposed to plywood. There are other issues just because an assembly wasn't designed right, or there was some major,
Katie, that's good. Okay. I need to go back to the mechanical. The one lead into that is kind of, you mentioned the unvented crawlspace, which is also a relatively new thing that a few of us had experience with. And it's a little bit of a misnomer because you need to blow air through it. And, it's one of the strategies is to blow indoor air through it to provide a minimum level of ventilation. It's not outside air, but that of course is somewhat in conflicts with the air tightness of the building. Like 1,000 square foot crawl space, you would need to have 20 CFM of indoor air going through it permanently. How have you dealt with that? Hopefully that's a segue back to your main subject of the mechanical. Thank you.
So, depending on your system, like let's just use our ideal best practice is a ducted whole house HRV. What we will do is just have an exhaust from the crawl space. So just like we're exhausting a bathroom, we also exhaust the crawl space. And then that just needs to be paired with a return grill, a transfer grill for that makeup air. And you don't need much. And so I don't know, I guess it hasn't been a concern for us. I think we're in a renovation where you might have, people just really don't, even after they do a major cleanup, they really don't want any, crawl space air kind of mixing with the home air. I think there are always individual situations that, you have to deal with. But even in that case, that's one reason we do like to exhaust into the HRV, because that's going out. It is going to be able to transfer that warmer air to the colder incoming air, which is certainly the typical condition. But so I don't know. Yeah, we haven't seen it being an issue or concern. But yeah, what do you think? Does that answer your question, or would there still be a concern from that?
I think it answers it. It's like, I mean, one other way to look at it, you do need to satisfy ASHRAE 62.2. So you need to have, a certain amount of fresh air brought in, even if you don't have recovery ventilation. And one way to do this is just to pull it through that crawl space before you exhaust it, basically. That's about the same amount, more or less, like for a normal house, something between, 20 and 40 cubic feet. And, before just pulling it out of the building, you just run it through that unvented crawl space. It's kind of one way to look at it, I guess.
Yeah.
But,
yeah, exactly.
Enough as a segue, I guess. Thank you.
Sorry,
then,
Katie.
Yeah.
There's one question remaining from the prior section about blower door. And the question is it difficult to locate the source of a leak when doing a blower door test?
It can be. I mean, it depends. If you're trying to get to passive house levels, and just for context, the requirement in the German program is 0.6 air changes at a 50 Pascal pressure differential between inside and outside. It's about equivalent to a 20-mile-per-hour wind, which is, a high wind in typical circumstances. And it can be really tough to get from 0.7 to 0.6. Everything's already so tight. But I would say it just depends. I would say that if someone isn't trying on a typical kind of more modest urban infill home, maybe they land at like 3 or 4 air changes at 50 Pascals. And it might seem like, oh, how could you ever get that to 0.6? That seems impossible. We've really found it's not. I mean, we've done a number of passive house projects and aren't doing anything, I don't think, that crazy to get down there. It really is just being thoughtful about having, a systematic strategy and doing that careful quality control. But yeah, it can be really hard for sure. And that's one reason why I think having enough mid-construction blower door tests is really important. Of course, that's not an option on a remodel. I think what you do is before you start the work, you do a blower door just to see your baseline. And then you might just set a goal like, hey, let's reduce it by 50% or by 70%. And then, then if you do a blower door without that baseline, you might not be where you thought you wanted to be and think like, oh, we have to try harder. But if you already cut it down by 70%, you might be like, hey, that's great. We don't need to keep hunting. Okay, so now on to mechanical ventilation. So just a quick highlight, and what we're going to talk about in this next section at the beginning is the whole house of mechanical ventilation requirements. There are, of course, requirements for direct exhaust in bathrooms and kitchens. Sometimes those requirements can actually tie into a whole house scheme. But just to step back and run through what code says is there's been an update in the last code cycle. This formula used to just be 1% of the conditioned floor area, and now it's 3% of the conditioned floor area. So it's basically 3% of the conditioned floor area, and then you assume 2 people in the first bedroom, 1 person in every additional bedroom, and 7.5 cubic feet per minute of fresh air required per person. So that's basically kind of what this equation means. So how it translates into a small ADU, it's about 30 cubic feet per minute. A 2,500 square foot home, 4 bedrooms would be over 100 cubic feet per minute. And this would be assuming you have an approach that is providing ventilation all the time. It's continuous. There are other formulas for if you're going to have it be like 15 minutes on, 45 minutes off. Don't recommend that for various reasons. We're just going to assume as a best practice baseline that you are going to do it continuously. So, okay, so we know we have to provide this. How do we have to do it? Can it be exhaust only? Does it have to be all supplied? Does it need to be balanced? Code doesn't say. It just says this is the amount of outdoor air essentially that needs to be brought in. Now, even though code doesn't care, it really does matter for air quality. And the worst one to avoid is exhaust only. If you're only exhausting, and this is the bare bottom way that people meet code. And I should say, this isn't triggered for, for a renovation in most cases. And I think it kicks in. If someone from Beyond Efficiency can confirm, I think if you're doing an addition of 500 square feet or over, that's when it's required, and it's certainly required for all new construction. But the issue with exhaust only is, so let's say in an ADU, you just are designating the bath fan to be on all the time, 30 CFM. Well, where's that makeup air coming from? Is it direct outside wildfire smoke air that isn't being filtered, or maybe it's it's in a home over a dirty crawl space? So that's the problem. You don't have control over where that makeup air is coming from. If you're exhausting 30 CFM out, you have to be bringing 30 CFM in. So that's why we really like, again, a balanced system. And we will talk more about, an option of how you can have a balanced, but with a pretty, with a very low cost approach. Oops, hold on. Okay, so again, it gives the occupant control when you do build tight to then ventilate right. So again, this is one of those other reasons, what I was just mentioning of circling back to why we do like to see balanced systems. It can contribute, if you don't have that and you're exhausting, you have an attic exhaust fan, the clothes dryer's running, it can backdraft the furnace or a gas water heater, which can kill people. It's not a super common occurrence, but it is an issue. One other reason why we love all electric, you just don't even have to worry about that. But aside from that, when you are balancing a system, you're not inducing, more, you're not inducing pressurization or depressurization, and it allows you to have, again, full control over filtering that supply air. And then to be even more efficient, well, and actually, sorry, let me jump back to here. So I'm sure a number of you have worked on projects where you have a ducted system for heating or cooling or both, and there's fresh air kind of integrated into that. And that's not a bad thing to do. We don't like it because it basically means you're compromising on something, in air quality essentially is where the compromise comes in. In the typical situation, you're only getting that fresh air distributed through the heating and cooling system when you are using heating or cooling. But what about those times when you aren't? Well, you can use that system to provide some fresh air, but now the ducts are way too big than they would be if you were just doing a smaller amount of ventilation only air, and you need kind of boost fans. And again, you're compromising. Now, much better than not having anything. So again, not to say that it doesn't have its place, but it's a best practice. We definitely really like to see a dedicated ventilation system. It's like, do your ventilation system, do it right, do your heating and cooling, optimize that for those needs. And then when you take that same mindset and apply it to offices, now it really starts to matter when we don't want to have, a COVID positive person spreading that to other people. And that's something, if we have time, we can briefly touch on at the end. So what we like, best practices is independent ventilation. Just do a system for ventilation. Don't mix it into other things. Do it in a balanced way, and then filter your supply air. And if you then want to ramp it up to the best version of that, you would do that all through a heater energy recovery ventilation system, which will just make the process of ventilation for health reasons also be as energy efficient as possible. So here's kind of this menu that Dan, one of many great one-pagers and kind of tools Dan's put together. So Dan's not on this call, but thank you to him through the airwaves. So, kind of from worst to best, here's how we can accomplish this code requirement for mechanical ventilation. You can just do, like I described before, just the always on bath fan. And your makeup air comes from wherever it's going to come, often from places you don't want it to, and you can't filter it. So we just say, please don't do that. Try not to. And a slight step up would be, okay, now we have the fan, but we're trying to encourage that makeup air to come from a place that we can control. Now, a big issue with this is to be able to control where kind of the makeup air, to balance the exhaust from something else, for that to work, a building has to be tight enough. If your building isn't tight enough, you've just sort of wasted money on a damper, and maybe a little bit of air comes through here, but probably not much. So, and if your home's going to be tight enough, likely you have a bigger strategy in mind, and you probably aren't really going to be into this. So this also we just couldn't encourage or recommend. So I think the starting point for like what I would offer is a minimum strategy for reasonable air quality would be, you start with that code minimum, just have a bath fan on all the time, and you pair it with a supply fan. And again, this isn't recovering heat. This is going to bring air in, whether it's 90 degrees outside or 40 degrees outside, but you are controlling where most of that makeup air comes from. So if this is running at 50 CFM, you run this at 50 CFM, and you can pair this with a filter. So then the question is, well, where do you place this? So maybe you would dump this into a laundry room that's already kind of providing some heat and won't cause discomfort if you were to dump it into the living area, for example. So this is sort of okay, we've got no budget, but we want to do a little better. What should we do? This is what we would recommend as a place to start. And stepping up for the bathrooms, you might just still have now a basic exhaust fan that is humidistat controlled per Cal Green. And then then you can do these just sort of spot ventilators, a ductless ERV. And there are a number of these products. This is just one example, Panasonic Whisper Comfort. There are some units that will run in pairs. One supplies air while the other exhausts, and then they kind of flip every 90 seconds. I didn't describe that very well, but we'll move on in the interest of time. But yeah, these can be really great for room-based solutions. You focus a smaller, simpler piece of equipment that doesn't require ducts, maybe just in a bedroom in a living space. So this can be again a really good solution. And these will have, again, filters that have to be replaced or to have to be washed or replaced. And then even better would be to have use an ERV or HRV that's ducted, but that you might still just focus this on a couple of the most important rooms and not really do a whole house system. And then the final best solution really would be that traditional best practice approach for installing a heat recovery or energy recovery ventilator, which would provide fresh filtered air to all the living and sleeping spaces and exhaust from bathrooms and other areas where pollutants are generated. Have questions come up, we can kind of pause for a minute.
Katie, I have a quick one on the Panasonic Whisper Comfort or ERVs in general. If you're pulling the stale, moist, stinky air out of the house in the bathrooms, an ERV transfers in the heat exchange some of the moisture back, but the purpose of a bath fan is primarily to remove moisture. How much of an impediment is that HRV versus ERV in this context of removing moisture from a bathroom? Have you had good experience with that, something like the Panasonic Whisper Comfort in bathroom ventilation, also acting as spot ventilation?
I don't know, Kara, if you know the answer to this. I don't know if this product is appropriate in a bathroom.
Yeah, they actually say on the data sheet, it's not intended to be used. That's why you would have to have a separate exhaust fan in the bathroom. And then the Whisper Comfort would go in your living room or in one of the main living spaces. So that is not a balanced option.
Yeah, it's not I mean, you can make it balanced. I did it in a couple of projects where you hack the supply. You just put a little 4-inch duct on the side, the little triangle, and supply it to an adjacent room, like a hallway or a bedroom or so. So then it actually acts like it's the cheapest version of getting balanced recovery ventilation into a building. The question is really just that heat exchanger core. A general question, ERV versus HRV. If the purpose is to get moisture out of a building, and the same is true for the fancier large Intellit balance unit that's in the middle of your chart there. That's also an ERV. So if you're using that to exhaust air out of a bathroom, are you removing enough moisture, or are you bringing the same moisture that you just removed back into the preheated air supply?
So the smaller CFM ERVs that Panasonic offers, it's a low enough CFM and a low enough transfer of the moisture recovery that I haven't seen an issue with that.
Okay.
It would be more of a concern with the Zender with the larger air exchange units. And then for those, I would recommend going HRVs in your climate. I would use ERVs in a cold climate where they have, dry winters and they want to keep some of that moisture inside.
And to your knowledge, is there anything like this integrated unit, like the Whisper Comfort Panasonic from another brand potentially, that's not an ERV but an HRV? Do they exist?
Zender has one, but I don't know if it's an ERV or an HRV.
It's really about kind of contractor friendly, like something that they know that looks and works like a regular bathroom fan. Contractors knows what to do. It's kind of the lowest threshold to kind of get it into the market, so to speak.
Right. Yeah. Zender has a Comfo Air 70 that it's similar to the Whisper Comfort that's installed in a wall.
Okay.
That does the same thing. I'd have to check it to see if it's an HRV or an ERV.
Okay, thank you.
Yeah.
Well, there is, so if you go to 475 Building Products, the New York kind of passive house focused company, they have their Lunos products, and I think it's called the Lunos Ego, and that is designed to be like a bathroom only ventilation solution. It might be an HRV. I actually don't know. I don't know if anyone on my team wants to take a quick look at it. We have it in our files, but yeah, so that's the only one I know of off the top of my head that would be appropriate, like basically a spot ventilator just in the bathroom.
I do think those
it is
are
expensive. It is, yeah, I would think,
Yeah.
since it's exhausting from a bathroom, so that would have to be drained. And no one's ever used it on one of our projects. I think it's hard to justify an $800 bath fan, essentially, is what it is. I mean, it is, it keeps the heat in, or helps maintain the heat in the bathroom, which is often appreciated, but yeah. Okay, and I'll talk a little bit more about kind of ERVs versus HRVs and selection ideas for that. Let's see. Oops. Okay, so these are these paired units I was mentioning before. It's literally a ductless ERV. So you can purchase, what this does is it's, again, instead of a dryer duct running through your wall, it's this ERV. And when they're installed in pairs, this is actually a ceramic core. So when this is in supply mode, this will be pulling in outside air, roughly 20 cubic feet per minute, and absorb heat from the ceramic core, so that then if it's 40 degrees out, it could be delivering it at 65 degrees inside. At the same time, this paired unit and they're talking to each other is in exhaust mode. So this is taking the indoor air, exhausting it out, and then the warm air is heating up the ceramic core as it goes out. And so then every 90 seconds, I think it's 90 seconds, they switch. So, this has gotten cooled off as the cool air has absorbed heat on its way in. So then it switches and now it starts to heat this up again. And there are thick units designed for, thicker walls that have, I think it's 93% recovery efficiency, which is pretty amazing. There aren't losses in there. There's no ductwork loss from those. I don't think Kate Ledger's on the call. I know that I think Carl had used one of these on a project and they weren't impressed with the noise. I don't know if it was Lunos or it was kind of a generic brand, because you can find these. There's another brand from places like Lowe's. But these really can be a great solution for ADUs or just situations where, you don't want to mess around with ductwork in terms of the space or the cost. So that's a good, these are pretty cool. This is what one of those looks like installed. And again, ERVs, energy rather than heat. It's also recovering some moisture. And and Kara, you might disagree, please jump in as you want. But, my experience and my view on it, I think in California, you can really use either one and be fine. Where I would say you would really want to be careful of using an ERV is in a space that has higher density, like a residential situation with higher density. So maybe it's a 750 square foot condo where there's a family of 3 living and they're cooking every day. That is the kind of place where you really want to get rid of that exhaust air. And, a 2,500 square foot home, family of 4, maybe cooking a couple of times, going out. In the typical situation, I don't see issues with ERVs in California, but I would, really be careful of like a smaller housing kind of project. What do you think, Kara? Do you agree, or would you?
I don't see an issue with the smaller ERVs. If I go larger CFM, I do tend to switch to an HRV just to be safe. But I agree with you. It's more of an issue. It completely depends on the usage of the occupants, how much moisture they're creating in the home. If they're not going to be creating a lot of moisture, not a lot of showers, not a lot of, using the rice cooker, the ERV can work.
So this is just an excerpt from a basis of design Kara recently wrote up for one of our projects. And we're not going to read this whole thing, but it might be a good reference for you in terms of how you might integrate something like this in your own projects. And on this project, we use something called the Comfo Air Q450, which we're going to talk more about. This is actually a self-balancing unit, which can be really great. Then in terms of, so this has been we've had a lot of conversations in our office and with colleagues about, well, how do we deal with wildfire smoke? What's the best way? So we had something we had looked at before and thought about was having a system that could add a carbon absorption filter to the say whole house ventilation system that would supplement the traditional or the kind of more standard MERV 13, which is a good level of filtration for particulates. The carbon absorption filter can capture gases, but then learning more in webinars and talking with other people, we've kind of gone away from that. And actually, yeah, Kara, I'll just talk another 10 seconds here and then we'll love to turn this over to you. And instead just really focus on the particulate. So, the issue with wildfires, if you're really in close proximity, there can be a lot of really bad gases that are released. It's not just a particulate issue, but with the typical wildfires, it does seem to more be a particulate issue. I think gases are going to matter more if there's like an urban fire and you're, a couple buildings away. I mean, there's all kinds of horrible stuff, right? That's going to be burned and in the air. But in the typical situation where we've landed is really just trying to integrate a HEPA filter. And Kara, I'd love you to talk a little bit more about what that looks like.
Sure. So for meeting California code, all of your ducted heating and cooling systems have to have MERV 13 filtration. So always there will be the MERV 13 filtration on the return side of any of those units. And most of the HRV, ERV manufacturers have caught on to this, and their standard filter might not be MERV 13, but a lot of them are starting to offer an optional MERV 13 to cover that. So if you're looking at an ERV or an HRV, that would be what you have, standard operation. The HEPA filtration, since there is such a large pressure drop across them, you wouldn't want to use that 24/7 year-round on your outside air filtration. But what we've found is having it as an option to bypass the outside air through the HEPA filtration unit when the outdoor air quality is bad is a good solution that doesn't have it operating all the time. What I've also found is you can have a HEPA filter that's 99.97% efficient, but if it doesn't have a good seal on it, you're getting bypass around that HEPA filter, which is reducing that efficiency. So you really want to make sure that whatever option you go with, they do have a good gasketed seal around it, so you don't have, you're not reducing the efficiency of it. The nice thing about most of the HEPA filters now is they are adding the activated carbon filter integral to that canister. So you're getting both the particulate filtration and the odor filtration.
And I think our first go around with this, you were looking at kind of a swap out process. And then a client said like, oh man, my homeowner's not going to want to deal with that. Can you just make it a switch?
Right. Originally,
originally
I was thinking, because the HEPA filtration unit that we've been looking at, the Hawk Environmental, has a built-in fan to power it. But to not have that fan operating, I was running it inline and just having the occupant put the filter into the unit when it was needed. Then I had a client say, well, I don't want to have to do that. I just want to flip a switch. So that's where we switched to this, where it's just a bypass. You do power the HEPA filtration unit and you just have a switch in a closet in the mechanical room where the owner can just go and flip the switch. Then it bypasses. When the outdoor air quality is good again, they can turn the switch off and the air will, the outside air will bypass, will just go straight to the HRV, won't go through the HEPA filtration unit because of the added static pressure. It just doesn't want to go that way unless it has to. So that's kind of how we settled on that as the standard.
Dara, is there any merit in MERV 15 as an intermediate step? I mean, when I looked at that recently, the kind of standard filter boxes, kind of 2 foot square, 4-inch thick, this seems to be pretty standard, and you can get up to MERV 15, the readily affordable filters. Is that a worthwhile step between MERV 13 and going all the way to HEPA, and also something that in terms of the resistance it puts into the static, it puts into the system, that's justifiable to be the default or not?
I would say no. I think the reason for filtration is twofold. This HEPA filtration unit is just to filter poor outdoor air quality, to filter that wildfire smoke. Inside on the heating and cooling systems that have MERV 13 filters, you're looking at that as the dust in your home, the pet dander, everything that's already inside your house, filtering that out so it's not being recycled. So MERV 13 to MERV 15, and we don't have that graph in here, but there's not a significant difference in the efficiency, what it's going to pull out of there, compared to the pressure drop, the added pressure drop that you're going to have on that MERV 15. And especially with a lot of new home designs or even switch outs from gas furnaces, they're going with the air to refrigerant mini split systems, and those forced air units can't handle a high static pressure. So I like to try and stay with either a 2-inch deep minimum, 4-inch deep if I can get it, MERV 13 filter box on those.
I have a quick question. You mentioned that, in designing this for outdoor air pollutants, the first idea was to have the owner shift something out and the second one was a filter. Is there another option where somehow the machine has a device that can attenuate to the kind of particle size or something? Maybe it's not always particle size, but is there a way for that to happen automatically? And perhaps there isn't, it's like $1 million, but I'm just curious.
You can always find controls to make anything like that happen. And I could see if they really wanted to make it 100% operating independent of any user feedback or adjustment, you could put a sensor in that outside air duct that, would go to a relay and turn the unit on and turn it off on certain parameters.
Might be good for elders, or people that aren't as mobile or something to have that.
Right. Yeah. I mean, you can pretty much do anything with a little bit more money.
Okay.
Yeah.
And then, what? Oh, go ahead, Mercedes.
Okay, just to finish up. So if this is with a ducted system, right, in the house. So what if one of the what if the way that it's heated and cooled is not ducted? And maybe you said this and I didn't understand. Can you have a sort of separate device that's doing this that that obviously isn't connected to the existing system because there's nothing to connect to? That sort of serving as a filter to the outside air as it comes. Maybe this doesn't make sense, but
I think this is a generalization, probably more for new home application. If you're doing a renovation, then it is going to depend on what they have. If they don't have a forced air system, you could do this similar setup on a supply fan.
Okay.
With the bypass to the HEPA filtration unit. You could just have, the portable HEPA filtration would be the cheapest solution if you don't have any ductwork in place.
Okay, thank you.
Yeah, and just to clarify for everyone, if anyone missed this, but this, all the stuff we've been talking about here, it is a dedicated outdoor air system. It's not integrated with heating or cooling.
Okay.
And so I guess really, Mercedes, back to like that and that, previous one, where, this, if nothing exists, there's no ventilation system, you want to do something, this would be the place to start. Just put a supply fan. And, we haven't tried to do this kind of through a HEPA filter, but there's no reason that couldn't be done, right, Kara? I mean,
you would have to power that HEPA filtration unit because that fan wouldn't be able to pull through a HEPA filter.
So they'd be sort of linked. They would both turn on together, but they would be operating separately, kind of?
Yes. So, Katie, if you can go back to the detail. So on this detail, that HRV is going to be operating continuously at whatever the code required CFM is. What we usually do is we have boost switches in the bathrooms that will increase that HRV or ERV to high speed if someone hits the switch in the bathroom and it has a setting on it. So maybe it's 20 minutes. So then it's going to boost to high speed for 20 minutes. And so that the airflow through the HRV is variable. The HEPA filtration unit is a set CFM. They've got two different models. I think one is 350 CFM, the other's 650. And there's other companies too, besides what we've specified on this project that have some different CFMs. But the CFMs aren't going to be matched, which is why I've got on that fresh air duct, I've got the arrows going both ways, because if that HEPA filtration unit is on, but the HRV maybe is only providing the 100 CFM continuous, part of that HEPA filtration air is going to recirc back into the HEPA unit, it'll, that's why you can't just have it in line if both the fans are operating. Otherwise they will be fighting against each other.
Thank you.
And hey, since we have just a little over 10 minutes, we'll try to power through. I want to share a quick anecdote. You know, we, back when the Santa Rosa fires happened, we had a client at a Mill Valley house, passive house level, well, passive house inspired, very airtight, and had a whole house ducted HRV. It was a Zender unit. And this, you know, the wife in the group, in a couple, she had always struggled with asthma like her whole life. And when all those horrible Santa Rosa fires happened, I guess it was the fall of 2017, I think it was that, but got this email from her saying, well, we haven't touched our unit, we haven't turned our ventilation down to low speed, but it's like, you know, it's so smoky outside, and as soon as I come in the home, we can't smell anything. And that was just, there was nothing, there was no HEPA filtration. They hadn't set their standard. I think it was running at 80 CFM down to 30. So just to reinforce this idea that, you know, with a properly designed ventilation system, you are talking relatively low CFM, relatively low airflows. And if you really have invested in a thoughtful approach to envelope airtight in the ceiling, I mean, it just goes so far. So a system like this is even, you know, that's the cherry on top, but you know, just basic ventilation where you're you know, filtering at least MERV 13 paired with a highly airtight envelope, you're going to be in great shape in pretty much any situation. So the one thing we haven't talked about here is kitchen exhaust. So what the heck is this? Anyone want to guess? So the code says you need 100 CFM intermittent. That means, okay, we're cooking, I'm just going to, you know, turn on the range hood, turn it off when I'm done, or 5 ACH continuous. What that means is if you were to calculate the volume of the kitchen, if you were exchanging 5 volumes of that kitchen volume every hour through just sort of a general exhaust, say into your HRV, or just a you know, direct sort of maybe wall exhaust fan, then that's how you can meet code. So what we recommend, just again, best practice as a given, is always to do direct exhaust with a range hood. Now, this is not a range hood. You know, we see stuff like this all the time, or you see a range hood that's, you know, 8 feet above the cooktop. It's really not going to capture. Sure, it might exhaust some general air, but it's really not capturing the particulates from cooking. But what's really important here is to size it right. Be sure to follow the installation specs. And then there's a question of, do you need makeup air? So, you know, if you've got a, you know, 6 burner Viking gas range with a 1200 cubic feet per minute massive range hood, you're going to need makeup air for that. If you have, you know, magnetic induction cooktop with a 200 cubic feet per minute hood, you know, code doesn't say you need it. If you do have a really airtight home, you might still need makeup air in that case, because, you know, Kara was mentioning static pressure in the case of a ventilation system. It's the same thing. If you have a really tight home and you're trying to suck air out, there could be so much, you know, static pressure that instead of pulling 200 CFM, it can only pull 100. And that exact thing happened to us on a passive house in Berkeley, where there wasn't makeup air provided with only like a 200 CFM range hood, but at the final testing, it wasn't even pulling 100 CFM. I don't know where it landed. Maybe it was at 90, but so the builder had to retrofit in makeup air. And then as soon as that makeup air was provided, you know, it shot up to like pulling 175 or something. And, you know, just to be clear, you could like crack a window, but code doesn't let you do that if you do need makeup air. So, you know, we discourage this. Do always encourage a properly designed range hood. And then here's just a little flow chart that we, you know, might be a way to think through, well, what if we've got this weird basement ADU we're trying to do, and to get this, you know, to get this cooktop properly vented through a range hood is all but impossible. I have to do a lot of gymnastics. Is there a way to avoid it? So this is just a little flow chart you might use. First off, we'd love to see magnetic induction. That should be step one. Lawrence Berkeley Lab has done lots of studies. I'm sure many of you have seen them on pollutants introduced from cooking. Those studies are almost exclusively related to gas cooking. There is a fraction of the issue with magnetic induction, not only because it's not using gas and having combustion byproducts from that, but also because of just how they work to cook food. We don't have a reference in there. That's something we can try to follow up on, but this is, just something to think through. Will it be gas? Yes, just do your direct exhaust. We really want to see that always as a given. And to clarify here, what we're talking about is, do you need that range hood, or can you just sort of do a general exhaust in the kitchen? So the question here is, range hood. I should reword this. So, and if someone's, cooking a lot, or they're doing a lot of real high heat cooking, really you want to see a range hood. The situations where I think you could argue, again, even though we always do want to see that range hood of, if there isn't a lot of cooking, you do have magnetic induction, they're just mainly, cooking mac and cheese on a daily basis. Maybe there you just do a recirculating range hood. You still do need to provide that general exhaust of the kitchen to achieve that 5 air change exchange rate every hour. And in terms of range hood design, Greenpoint Rated has a great measure that just captures really the best practices. So would love to refer you to that. Often when you really look at the distance from the bottom of the range hood to the top of the cooktop, I almost always say range hoods installed too high. So anyway, yeah, pay attention to that. So some great information there. And we mentioned this idea of a self-balancing HRV or ERV. So if you are doing a whole house ducted system, part of the commissioning of it before you turn it over and say the work is done is to make sure that the air flows that were designed are being provided, either what you're exhausting from the bathroom or supplying to the bedroom. That process can be made easier through these self-balancing units. And then if there is temporary depressurization because, say, the dryer is running, exhausting air, or for some other reason, it will kind of self-balance, which is kind of nice. And these self-balancing ERVs in theory could be used to preclude the requirement to have makeup air for a range hood. But a challenge with doing that is that then and actually let me step back. So usually this unit will be, let's say, supplying 100 cubic feet per minute at the same time it's exhausting 100 cubic feet per minute. What if you have a range hood operating at 200 cubic feet per minute? Instead of supplying air, these will temporarily reverse direction essentially and they'll all turn into supply. So, if you're exhausting 200 CFM, you need to make up with supplying 200 CFM. So instead of exhausting the bathroom, maybe 30 CFM is how you have it set up, it would be supplying 30 CFM. So if that happens, if someone's in there showering and someone's also cooking with a range hood on, that could pose an issue. So any other thoughts on that, Kara?
My thought would be, I would highly recommend that the kitchen hood exhaust makeup air is separate from the HRV. It's only, I would say, in a very small kitchen hood exhaust that I would consider doing that. Just because it does take away from the purpose of the HRV. Maybe if you had a 100, 200 CFM hood, which I don't see very often.
Right.
You could look at that.
And we have a couple slides here on offices. I think we'll go right to Q&A since we just have a few minutes left, but we'll leave this in the slides, but this just does show a scheme for how you can implement a DOAS, or again, dedicated outside air system in an office space. It's essentially, same thing as you do it in a home. It's just you do your heating and cooling in one system, you do your ventilation in an independent way. And it's very rare to see this in commercial. It's actually required now in Washington State, and love to see it be required in California. And this just captures some best practices that Kara had written up for that same project. And basically the best practices being integrated in this project, which will be an office building for, minimizing COVID risk, minimizing transmission within that office space. And really the key takeaways are to do an independent outside air system, and then zone your heating and cooling so that, a whole building isn't recirculating. And yeah, not much time for questions, but I think we did have a lot of good questions come up throughout. So yeah, what remaining questions do people have?
I have one. You just a few slides ago touched on the kitchen and the fact that it would still need the general exhaust in the kitchen of 5 air changes per hour.
That's if you're not doing a range hood.
So otherwise the range hood takes care of that, is the idea.
Exactly.
Okay.
And I bring that up. It's not something we often see, but passive house, people who are maybe get a little too caught up in what I would call the ideals of passive house, think that it's, they really don't want to have a direct exhaust. So they'll do a recirc hood with a general exhaust into the HRV. And, again, in almost all cases, we really discourage that. I think you can justify it. You have magnetic induction. It's some unit catered to a 20-something person, never cooking at home. But yeah, so that's the answer on that. You don't need both. It's one or the other.
Okay. Great. Well, thank you so much. Really appreciate it, Katie and Cara. And thank you for the offer to send the slides out. That would be great.
Yep, we will. Yeah, we'll definitely do that and try to include a couple other resources on some side conversations we had. So yeah, and nothing else has come up in the chat.
Compliments, thank yous. Okay. Oh, so here's one. Sorry, I missed some of these. Yeah, we have a few. Sorry, guys. I'm going to skip the roof one. What do you recommend for fresh air in an airtight home with radiant heating, but with no mechanical ventilation except for the bath exhaust and the range hood? So fresh air in an airtight home, radiant heat, and just the bath and the range hood as mechanical. And then a few more questions as well.
Yeah, so going from, at the more basic level, you could just provide a supply fan. If there's a laundry room on the outside wall, just put a supply fan into that room. You match it with a bath fan that's designed to be on all the time. And, depending where you place those, there'll at least be some sort of air exchange, but it's not going to be kind of a whole house system. And there could be some rooms that really aren't at all addressed in that. Depending on the feasibility, you could do a spot ventilator. The ideal would be to do a ducted system. So it depends on, what's your attic? Do you have space where you could run some ducts in an attic or a crawl space? One nice thing about ventilation systems is because we're dealing with really low volumes of airflow, you can deliver that air with very small ducts. So Zender has their proprietary, we now have to actually use a flex duct, but it'll fit in a 2x4 wall. So that does open up possibilities, but if you aren't otherwise planning a remodel or you don't really want to open stuff up, that would be my first thought as well. Could you do something in a discrete location, run wiring to like an on the wall spot ventilator for the living room or maybe a master bedroom? That's my first thought. What would you say, Kara?
I would agree with that.
Okay.
Ideally, you've got an HRV, but that's only if you have an attic or crawl space to put it in. If you don't, I'd go with what Katie said with the supply, which is the fan.
Katie and Kara, this is Carol Shannon. That was my question because we're in a middle unit condo with no exterior wall except for the two ends that
Mhm.
are, double glazed with a door, and there are no crawl spaces. There's no attic. there are no ducts. So, during the fires, all I could do was put in air filtration inside the room we'd stay in because there
Right.
is no fresh air except by opening doors and windows and turning on the fans.
Yeah, I mean, and that could, in theory, that would be the perfect sort of situation for doing these ductless Lunos paired units. But even that, you're in a condo, you've got to get wiring and open stuff up, and it's very
I think
technically
the
feasible.
Lunos does have a wireless option
Oh,
to do those. You could
well,
also
to
look
talk
at
to each other, but you still need to get power to it, obviously.
Oh, yes.
But you
And
could
that would
always,
be true of any of them.
would you just be able to tap into your regular
Might
outlets?
be able to, depending
Or
on
would
the
that not
circuitry.
be like kosher with electrical code?
Oh, yeah, I don't know if they need a separate circuit.
Yeah, exactly.
Yeah, I've seen it done before for a little electric wall heater in a bathroom. So I would think it could be done, but I know the work on that wasn't permitted. So I can't say that it was code.
So Carol, if you want to do the work yourself, maybe that would be an option.
And spell Lunos, please.
Lunos.
Okay.
And Lunos, I believe they're 18 CFM. It's a fairly low CFM. If you look at the Zender Comfoair 70, I think they're at around 35 CFM.
Okay.
So we have another question on ventless dryers from a couple of people. What is your take on ventless dryers or your thoughts about that?
I love my heat pump ventless dryer, and I'm glad you mentioned that because I meant to kind of comment on that when I was talking about the depressurization. So yeah, you can do condensing ventless dryers. They essentially drain water that's been captured rather than exhausting moist air. And you don't need to vent. And in our heating dominated climate, it adds heat to the space. That's not always a good thing, but usually certainly on a net annual basis, that's a big benefit. And again, you don't have to deal with venting, which is great. So but yeah, I'm a fan. Some people don't like them. You have to change out two lint filters. To me, it's not a big deal. But there are differences. Like there's what I encourage are the heat pump condensing dryers rather than just condensing. It's a little bit still anecdotal from my own experience, but I have experiences with two types: a non-heat pump condensing that was actually an all-in-one washer dryer, pretty small volume, and it would take a long time to dry clothes, which wasn't a big deal. I wasn't going to the laundromat. We had retrofit this into a condo in Berkeley years ago. But it did take a long time to dry clothes. And that's one complaint people had. But again, my current large, like 7 cubic foot volume dryer, heat pump condensing, it works amazingly well. It heats up our freezing cold basement otherwise. So yeah, and that's another thing actually we could link to. We have kind of a inventory of heat pump condensing dryers. Bosch, Whirlpool, LG, I think, and there are a couple other models too that we could include in the follow-up.
Great. And then we have one last question regarding the range and makeup air in a space without an HR. Can the makeup air for a moderate sized hood be an open window? We have an HRV system throughout as well. So that's obviously an existing home situation.
Well, I get
sort of
confused
a workaround to make up air, I guess.
I get confused between the general national code in California. I'm pretty sure it's still 400 CFM or higher rating on the range hood where makeup air is required. Is that
that's
right?
for the international code. In California, they actually don't stipulate that.
Yeah.
So yes, you can have an open window. That goes back to air quality outside. If the air quality is good, they'll open it. If it's not, they're not going to. And then the hood's just not going to exhaust as much.
So what would be like an inexpensive sort of workaround to kind of an existing home, like one of the ventilation fans with, I know we've sort of covered this, but it's getting sort of swirling around in my head like a washer dryer.
That would be interlocking a supply fan with a filter with the hood, which is fairly easy to do as long as the kitchen exhaust fan is smaller.
Oh,
Once the kitchen exhaust fan gets larger, I would say 400 or above, then that interlock with a supply fan just those supply fans are usually meant for smaller CFMs. So then you kind of get into the Fantech has a makeup air, you know, the fan, the filter, the sound attenuator, the whole deal, motorized damper. You get into a little more expensive makeup air.
great. Thank you. Well, any last questions from anyone? No, thank you so much. Really appreciate it.
Thanks, sir.
Thanks,
This was
Donald. Thanks, AIA.
Yeah, and this was Mercedes' topic idea. So thank you, Mercedes, to prepare. Hopefully was informative. And yeah, and again, anyone's welcome to send follow-up questions to us. And we will get you those slides tomorrow, add in a couple other resources. And yeah, thanks for everyone's time.
Thank you
And
so
have
much.
a great day.
Take care. Bye.
Bye, everyone.